So for this video, we're going to go back over everything that's been in our unit so far for geometry. So to start with, we looked at the Pythagorean Theorem, which is a squared plus b squared equals c squared. And it's actually, if you know it's a right triangle, then we can use this formula. And the only important part is that c is your hypotenuse, which is the longest side, and it's across from that right angle. So for example, if I said that we had a side length of 4 and 11, and I wanted to know this side length over here, I'm going to plug it into Pythagorean Theorem, where 11 is my c, so x squared plus 4 squared equals 11 squared. X squared plus 16 equals 121. And then we can subtract 16 from both sides to get x squared equals 105. Alright, to get x by itself, I then have to take the square root. So then we get x equals the square root of 105. Now you should always try to simplify. So I know it ends in a 5, so that means 5 goes into it. So it's going to be 5, and then 100 divided by 5 is 20, plus 1 more, 21. And then 3 and 7 go into 21. I don't have any pairs, so there's nothing I can take out, so that means I can't simplify. So that side length would just be the square root of 105. Alright, then we looked at the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I had the points 7, 3, and negative 5, 8. Okay, it doesn't really matter which x I start with as long as the x I start with in this parentheses is the same y I start with in this parentheses. So if I pick the first one, we'll say 7 minus negative 5 becomes 7 plus 5 squared, and then 3 minus 8 squared. Well, 7 plus 5 is 12, squared is 144, and then 3 minus 8 is negative 5, squared is 25. Oop. So 144 plus 25 is 169, and the square root of 169 is 13. So the distance between these 2 points is 13. Okay, midpoint is we're adding, so order doesn't matter, so I just add my x's, divide by 2, add my y's, and divide by 2. So if I use those same points, 7, 3, and negative 5, 8, then I would say 7 plus negative 5 divided by 2, and then 3 plus 8 divided by 2. Well, 7 plus negative 5 is 2, so I end up with 2 over 2, and then 3 plus 8 is 11. And 2 divided by 2 is 1, and I can't simplify 11 divided by 2, so I'm going to leave it as 11 over 2. So my midpoint would be at 1 11/2. We also looked at area and volume of different shapes. Now we made a foldable, so we have different shapes we looked at. But for example, if I wanted to find the area of this triangle, alright, and we'll drop this down here and say that that's 4, which it might not be. Alright, but I just made this one up. So to find the area of a triangle, we have 1/2 base times height. So I have 1/2 times my base 10 and my height 4. And the reason I use height is because, or the 4 for my height is because it makes that right angle with my base 10. So multiplying by 1/2 is the same as dividing by 2. So 10 divided by 2 is 5, and then 5 times 4 gives me 20. So you get 20 square units for that triangle. And again, we made a foldable with all the different formulas that we use and the different shapes we find the area for. We did the same thing with volume. So for example, if I had this shape, I will say that this is 8 and this is 4. Right, so this is a cylinder, and so to find the volume of a cylinder, it's pi r squared h. So my radius is going to be 4 because it's half of my diameter, 8. So you have 5 times 4 squared times my height, 4. 4 times 4 is 16. 16 times 4 is 64. And we'll leave it in terms of pi because this is our exact answer. So we'll leave it as 64 times pi as opposed to actually plugging that into the calculator and getting it a rounded decimal. And lastly, we looked at triangles versus quadrilaterals. So for triangles, we classify them 2 ways. One by sides, where we have an isosceles, where 2 sides are congruent, an equilateral, where all 3 sides are congruent, and a scalene, where no sides are congruent. Okay? To classify, whenever we're looking at our triangle by sides, you got to use your distance formula. That way we can figure out the length of our three sides of the triangle to see if one or two or none of the sides are congruent. Then we also classify by angles. So we have a right triangle where there's a right angle. We have acute, a special kind of acute, which is equiangular, and that's for all the angles that are the same, and they're 60 degrees. And we also have obtuse. Now equiangular is going to go along with equilateral. Right, so if it's equilateral, we know it's equiangular. But to do the angles, we end up looking at parallel versus perpendicular, or slopes, which in this case, we would use perpendicular, because none of the sides in our triangle are going to be parallel, or it wouldn't be a triangle. So we look to see if there's perpendicular, compare our slopes to see, what kind of angles we have going on inside of that right triangle, or of the triangle. Quadrilaterals, we kind of have our big umbrella for quadrilateral, and we have the option of a kite, parallelogram, and a trapezoid. Right, so a kite has consecutive congruent sides. So you have two sides that are back to back that are congruent, two sets of those. A trapezoid, we have one set of parallel sides. And a parallelogram, we have two sets of parallel sides. To get more specific, I can have a rectangle where I have opposite sides parallel and 4 right angles. Or I could have a rhombus where I don't have right angles, but all of my sides are the same. Then both of those can lead us to get even more specific and get a square where I have all the sides are the same and 4 right angles. So this is what we've been looking at in our geometry unit thus far.